Factor in trinomials when the leading coefficient is not 1. We consider this level easy because A, the leading coefficient, only has one factor set, 1 and 7. And then same thing with the 5. It only has one factor pair, 1 and 5. So we're going to consider all the cases. We don't know which one it's going to be. So it could have been 1x and 7x. And then maybe it was the 1 and the 5. Or maybe it could have been the 1x and the 7x, but maybe the 1 and the 5 were switched around, so maybe it was the 5 and the 1. So what we're going to do is just we're going to have to test. So that gives us 7x squared, and then we have a 5x, and then here we get a 7x, and then at the end we'd get a 5. Down here we'd get a 7x squared plus a 1x, and that would give us 35 x's, and then plus 5 at the end. So obviously this is the case we want right here. So we just have to figure out how do we want these 5s and 7s to combine to be a negative 12 in the middle, and in which case we'd want them both to be negative. So if we had a negative 1 and a negative 5, that would make this negative and that negative, which would be our negative 12. So we factored it into x minus 1 and 7x minus 5. We consider this a level 2 because the factors of A now have more options. This one could be a 1 and a 4 or a 2 and a 2. The factors of C could also have more options now, 1 and 15 or 3 and 5. So here what we're trying to do is we're going to eventually combine them to be 16 x's. So what we have to do is consider what it could be. Maybe it's 1x and 4x, and maybe it's 1 and 15. Or maybe it's 1x and 4x, and maybe it's 15 and 1. Maybe it's 1x and 4x and 3 and 5. Maybe it's 1x and 4x and 5 and 3. Now the idea here is there's going to be a lot of options, because now we also have to go consider if we used the 2. So maybe it was 2x and 2x, but we don't know which combination would have been used for the 15. Maybe it was 1 and 15, maybe it was 15 and 1, or maybe it was 3 and 5, and 5 and 3. So the goal is for us to find which combination after we multiply would give us some sort of 16. All we need to do here is check the inner terms when we multiply, the outside and the inside, because we know all of them, of course, will give us 4x squared, because 1 and 4 and 2 and 2 will always be 4x squared, and the last terms will always end to 15. So here we'd have a 4 and a 15. 4 and 15 is not 9 or 16. So it's not this one. Here we would get a 60 and a 1, which is not 16. So eventually we want to start to see the pairs 5 and 12, that's not going to work either. Here we have 20 and 3, that's not going to work either. So here you want to think and pause maybe and ask yourself, do you see where you could get a 6 and a 10? Because a 6 and a 10 would make 16. And eventually we're hoping that as you're looking at these factor pairs, you realize that they all get multiplied by each other and then added. So what I can see is if I took a 2 and multiplied it by a 3, and I took the other 2 and multiplied it by a 5, that would give me 6 plus 10, which would be 16. So down here, I can see that I want to use the 3 and the 5, and the 2 and the 2, so it's not going to be those. So it is going to be one of these, And in this case it doesn't matter because I see that in both cases they're the same. This would give me 6x, that would give me 10x, this would give me 10x, that would give me 6x, because they both have 2x in front. So this is our answer. So our final answer is 2x plus 3 and 2x plus 5. Here we have a level 3 factoring because there's a lot of different options that we could have for our factors of a and c. So one thing I check for when I see large factors of a is always check for that GCF, and unfortunately there isn't one. 17 is a prime number, so it's not going to have any factors. So for 24 there's a lot. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. For 20, or negative 20, however you want to see it, again there's a lot. 1 and 20, 2 and 10, 4 and 5. Now for this one, there's going to be way too many cases for us to write out totally. So what we're going to do is we're just going to try to find somehow, we're going to use some number patterns to get numbers that add up to 17. And what we have to remember is we got to pick a factor pair here, and these numbers will be multiplied by the factor pair here, and then we'll combine to somehow give us a positive 17. Now, since this is a negative number, we know that one of those groups is going to be positive, and one of those groups is going to be negative. Ultimately, the group with the the group with the positives needs to be bigger than the group with the negatives, because when we combine them together, we're left over with more positives. So if you have the factor pairs listed, you're going to start testing them, and you'll be able to pick a pair, so like 1 and 24, and pair it with another one, like 1 and 20. So 1 times 1 would give you a 1, 20 times 24 would give you a big number, over 400. That's obviously not the scenario, so maybe the order was switched. Maybe the 1 should be multiplied by the 20, which would give us a 20, and maybe this one should be multiplied by the 24, which would give us a 24, but we can't make that combine to a 17. You can obviously avoid some obvious wrong answers. For example, if I were to choose the factor pair 1 and 24, and then try the factor pair 2 and 10 for 20, it's pretty clear to me that I would not ever want to try multiplying those two together, because that's going to be a number over 200, and it's just never going to work to be a 17. So we would avoid those easy factor pairs. So we continue to test factor pairs. So maybe it was 4 and 6 for the 24, and maybe it was 4 and 5 for the 20. So if I multiplied those two, that would give me a 16. If I multiplied those two, that would give me a 30. I can't make a 17 using 16s and 30s. So maybe the order was wrong. Maybe I was supposed to multiply the 4 and the 5, which would give me a 20, and the 6 and the 4, which would give me a 24, but I can't get those numbers to combine to be a 17 either. That eliminates those factor pairs together. So here, I would encourage you to pause the video and start looking for those factor pairs. Start testing them and try to find a pair that you could somehow get to a 17. Your hint as you're practicing this is you could get a 32 and a 15 to combine to be a 17. So take a moment to try to get that on your own. And the way, now that you're coming back after you practiced on your own, the answer, like where would we get the 32 and the 15? Well, what I can see is if I had an 8 and a 4, that would give me the 32. And then therefore the other two numbers, 3 and 5 would give me the 15. Now, in this case, in order to combine to be 17, the bigger number needs to be positive. So 32 is going to be positive, and 15 is going to be negative. Now, we're going to come back to that in just a moment. What does this mean for us? So now we know what our factors of 24 were. The factors of 24 always go first. So the first factor is going to start with a 3. It doesn't matter if you start with a 3 or the 8. So 3x will be in one parenthesis, and 8x will be in the other. Now, we also know what numbers we want to use for c. For c, we know that we want to use the 4 and the 5. Now, when we use the 4 and the 5, though, we have to take caution on where we put them. We'd be very tempted to put the 5, which I incorrectly wrote down here. We'd be very tempted to put the 5 with the 3 and the 4 with the 8, because down here that's what we did. But that's incorrect. If we were to do that, when we multiply it back, we would get a 12 and a 40. And that wasn't what we intended. So what that tells us is we need to flip the position of the 4 and the 5. So when the 3 and the 5 need to be multiplied, what that tells us is that they need to be in separate parentheses, because the only place where that 3 is going to be distributed when we multiply is going to be to there or to there. And if I want the 3 to be multiplied by the 5 so we can get that 15, we know that the 5 therefore has to go here. And likewise with the 8, the only place it's going to be multiplied is here with the 3x, or here with that spot. So if I want the 8 to be multiplied by the 4 is going to have to go there. Now the last part we have to address is the positives and the negatives. When we factor, we want our leading coefficient to be positive, as it is up here. This was a positive 24. So we're always, emphasizing always, going to keep the numbers in front of x positive. And anytime we need negatives, we're going to make the numbers negative. So in this case, if we wanted the 15 to be negative, that means the 5 would have had to have been negative. So we always make the factors of c positive or negative. So our final answer, clearly written, would be 3x plus 4 times 8x minus 5. We can always check by using the multiplication. 3x times 8x is 24x squared. 3x times negative 5 is negative 15x. 4 times 8x is 32x. And positive 4 times negative 5 is negative 20. So we can see that we have 24x squareds. Combining these, we get 17x's. And then at the end, we have a negative.